Hello everyone. So this Tuesday I have a doctor appointment. So I just changing this class as a lecture video. So thank you for your understanding. And by the way, I'm sorry. We have our test 3 or exam 3, test 3 uh, next next Tuesday. Okay. So almost this class, the last class for test 3. So this Thursday we will go over, we will review for this test. So I hope this test is also easy to everyone, so you can get a good score. Okay, so the topic for today is radio and degree and then graph. We say talking about radio, degree, and graph of trigonometry functions. So last class we discussed the relationship among those trigonometry functions. So we have sine, cosine, tangent, cotangent, or secant, cosecant. We have 6 trigonometry functions, but those functions are closely related. So this means if we know one of them, we can find all others. So we refer to such a problem as giving one, find others. Okay, so let's review. So let's say, so for example, we have such a problem. We have an angle. We have an angle. Its tangent is thus. We want to find sine, cosine. So for this angle theta, so we usually we use large triangle. We use large triangle to denote this angle theta. Suppose this angle is theta, and for this angle theta, we know the tangent value, like tangent theta equals 3/2. So tangent is we know this ratio. So this over this is 3/2, right? So this angle is tangent 3/2. So we want to find this sine, cosine. So in order to find sine, cosine, so we need to find this side. So let's say what is the hypotenuse? This is 2, 3. So a square, b square, 2 square, 3 square. I think it's 13, right? Okay, so from this large triangle, we can easily find those values. Sine equals 3 over radical 13. Cosine is 2 over radical 13. Right? Okay, so then we need to determine, we need to check a positive or negative. So we say this angle is in third quadrant. So third quadrant, we just use this. All students take calculus. So the angle is here, third quadrant. Like this angle, just like those angle, this angle, right? Okay, so for such angle, so in third quadrant, so we know sine, cosine, both of them are negative. Only tangent is positive, right? So find the answer is sine equals negative 3 over like cosine equals this. Okay, so for angle, so we also use arc sine, arc cosine, arc tangent. So we have those. So now we have such a problem. We want to find tangent this arc. So tangent this arc is just like find tangent this angles, tangent theta, tangent this angle, right? So what is this angle? So this angle is okay. I'm sorry, I made a mistake. I should have parentheses, right? Ah, but tangent this angle. Yeah. So this angle is what is this angle? This angle is arcsine. So let's say so we use this large triangle to denote this angle is theta. So its sine is 2 over 3. So sine 2 over 3, so we should put 2 here, 3 here. So this angle is sine is 2 over 3, right? So if this side 2, this side 3, we can find this side. So I think this side, yeah, I find this side is radical 5. So you should make sure where this radical 5 come from. So use a square plus b square equals 6 square, right? So from here, we see from the large triangle, we can easily see, oh, there's a tangent equal 2 over radical 5. This is tangent. So positive, negative. So we say for a we always use positive. Okay. So those are topic of last class, right? Okay. So we say for angle, originally just come from a large triangle. So okay. So this angle theta. So we have this now. We say theta. So the angle is usually between 0 to 180 degree. So for any angle in a triangle, this theta is between 0 to 180. But we mentioned angle can be any angle, right? So we can use any degree. So we can use the general angles definition. So angle, so far angle we use degree. But in our calculate, we have radial measure. So angle, measure angle, we have 2 ways. Degree, use degree, and use radial. So here we have 2 questions. First one is, what is radial? And second one is, why we need the radial, right? So first one, let's check out first the question. What is radial? So we say an angle is formed by this way. Sorry. Initial side, we see, right? Then turn the initial side to this position, so we can have angle. So the angle is big or small, determined by this arc S. So like if we turn to here, the angle is big, then this arc, this S is also big, right? So to measure the angle is big or small, we can use this S. Okay, use this S. But this is also related to this R, right? So we just use this S of R to measure the angle. So if this is big, then this angle is big, right? So we just use this number. We denote this number as theta. We use this to measure angle. So this is a radial. Okay, so this is just a radial. So what is radial? Radial means just use usual number to measure this angle. So let's say, what is this angle? Theta equal 1. What is this angle? So this means like this ratio is equal 1. So this means here, suppose this is R, then this is here is also R. Okay, the same. And then this angle is, we say, 1. Okay, so what is 2? So theta equal 2 means this angle. So this is R, and here is 2R, right? So this angle is 2. Okay, R and 2R. Okay, so this is radio. Okay, so then we will say why we need the radio. So before we use the degree, angle, or in triangle, in solving triangle problem, angle always degree. So why we need this radio? So this radio, from here we can say, what is the radio? Radio is just the usual number. We use usual, let's say, usual numbers to measure angle. So for this angle we can use the 1 or 2 or 1.2, 1.3, 1.3. I use this usual numbers to measure angle. Okay. Okay. So here to measure angle we have 2 methods: degree and radio. So what is their relationship? So we check where. Let's check it out. Where the degree come from. So degree just come from, we define like this large angle is 90 degree, right? So where does 90 degree come from? So this is just come from our definition. Our definition for angle is, we just say like if turn around, such angle is 360 degree. Okay. So then like okay, so flat angle is 180. Then large angle 90. So this 90, large angle is 90 degree. Just come from this way. Okay. So okay, so turn around in degree is 360. Okay, so in radio, let's say suppose this is R. Okay, then turn around. Then let's say what is this angle? What is S over R? So if we turn around, then this S become the circumference of the circle. So we know this S is 2 pi R, right? 2 pi R. Okay, so this angle, one circle turn around is 2 pi. So the relationship between degree and radio is thus. We say this angle 360 is equal to pi. Okay? So we cancel 2, so we just use this. We say 180 equal pi. Okay? So 180 equal pi. So this is the relationship between degree and radio. Okay? So sometimes we use this formula, so we can easily convert from degree to radio and radio to degree. So let's check some examples. Like let's say, how about we just change 60? We want to change those angle in degree to radio. Okay, from degree to radio. So 60. So I suppose I just know 180 is pi. right? 180 is pi. I just remember this 180 equal pi. So what is 60? So 60, we just check 60 equal how much of 180? So we just say 60 equals 60 over 180. So much of 180, right? 60 equals so much of 180. So for this ones, we can, for this 60 over 180, we can simplify. And this 180, I changing this to pi. Okay, so it's like 60 over 180 pi. So this one we can simplify. So we say this equal 1 over 3 pi, or we write this as a pi over 3. Okay, so such a problem is easy. We just changing this equal how much of 180. So same way like this one like 150. So we just use this 150 equal how much of 180 equal so much of 180, right? So we just change this 180 to pi, and then this fraction we just simplify. 15 over 16 is 5 over 6. Change this to 5 over 6 pi, right? So in radio, we keep this pi. We don't need to change pi equals 3.14 something something. We just keep it as a pi. Okay. So typically at a 90 degree is half of 180, the pi over 2. Okay. And so we just 90 degree the pi over 2. Now 45 degree is, oh, I'm sorry, I made a mistake here. Why I got this? I made a mistake here. So let's say 45 equal, we forget a negative, part of negative, equal 45 over 180. So 180. So 45 over 180 is just 1 over 4. So 1 over 4 pi, right? Okay. So then let's say we convert radio to degree. So I just remember pi is 180. So for this one, I just change this pi as 180, right? So 180 over 6. Oh, this equals 30 degree. So 30 degree in terms of radio is pi over 6. Okay, so here the same, right? So if we have a pi, we just simply changing pi to 180. So here no pi. Like for this one, let's look negative 1.2. So equal. We want to change it to degree. So here I just remember pi is 180 degree, right? So for this one, 1.2, I just wanted to check how much of pi. So here I use pi as a unit. So 1.2, I'll keep it negative. 1.2, so how much pi? So equal divided pi times pi. So much of pi, right? So this pi, I replace this to 180. Okay, 180 degree. So this equal 1.2 or pi multiply 180 degree. So this equal, we can say that's equal just 1.2 multiply 180 over pi degree. So here we just got a pi as a regular number, like 3.1415 like this. So use calculate, we can find this. Before we should remember this pi, but by now our calculate save this pi. So we have pi button. right? So you just do this way: 1.2 multiply 180 divided by pi. So this number is just a degree. Okay. So here's the same story: 3 radio 3. So we just check equal 3 equal how much of pi? 3 equals so much of pi, right? So this pi, I just changing, replace this pi to 180 degree. Okay, so this equal 3 times 180 over pi degree. Then we need to calculate to find this. Okay, yeah. Okay, so then there's a conversion between degree and radio. Easy. I just remember 180 equal pi, or pi equal 180, right? Okay. So we have typical angles like a 30 degree, 45 degree, or 60 degree. Those or 90 degrees. Those are typical angle in degree. So we can easily convert them, those typical angle, in radio. So like a 60 is pi over 3. So 30 degree, pi over 6. 30 degrees is 180 over 6, right? Pi over 6. And 45 is pi over 4. And 90 pi over 2. So we have those. We have those typical angles in radio. Okay. Okay. So by now we know what is radio. And so we say radio is just the usual number. Right. We just use usual numbers to measure angle. So by now angle is not degree, angle is this angle is 1, angle is 1.2, or angle is 0.5, or angle is negative 3.4. So so the angle and the numbers are the same, right? Okay, so once we understand the radio, so we can answer the question: why we need those radio? So before, for angles, we use degree, right? We use degree. But why now? Why by now we in, let's say we say in engineering, maybe they still prefer use degree. But in mathematics, in modern mathematics, we use radio. So why? So one for the reason is a graph. Let's say for graph for any function, we usually focus on graph. We want to know its graph, right? We want to know how the function changes. So so far we discussed like a polynomial function, like y equal x squared. So here we put this graph, there's a rectangle coordinate. Okay, so this y square. So for rectangle coordinate, this unity for x and y the same. So x and y the same, just a usual number. But if we use degree, like let's say y equals sine x. So if x degree, so we say, oh, this x axis degree, right? Degree. And here y usual number. So here's 180 degree, here's 1. So this is like so this function graph, this is and y equal x squared, and the line coordinate not the same. So here we prefer to unify them. We regard trigonometric function and polynomial function, same thing, almost the same, just from number to numbers, the mapping from number to numbers. So for this reason, we prefer here we prefer use radio, not degree. Okay. Okay. So now we can focus on graph for trigonometric functions. So let's check this function y equals sine x. So to get its graph, we just pick some points. Then connect those points, we can get a graph, right? So for y equals x squared, we usually pick these points of x equals 0, x equals 1, x equals 2, like this, right? So we say we just pick some typical x value. So those typical x values, we just pick some simple values. We will pick x equal 1. We do not pick x equal 0.995, right? Okay, so for angle, so here x is angle. So we just want to pick some typical angle. So typical angle is like those typical angles, like 45 or pi over 4, pi over 2, right? So, but we here we pick very few of them, so we just pick those typical angle. Let's say angle here 0, saying 90 degrees. So by now we say pi over 2. So pi over 2, saying another pi over 2, saying another pi over 2. So here pi over 2, pi over 2, pi over 2. So we use pi over 2. We just pick those points. X equals 0, sine equals 0. So from calculating, so x equals pi over 2, sine pi over 2 equals 1. So x equals pi, sine pi is 0. So x equals 3 pi over 2. 3 pi over 2 is just pi over 2, pi over 2, 3 of them here, right? So we find the function value sine is -1. And so turn around to here pi over 2 pi, pi over 2, pi over 2, pi over 2, pi over 2, 4 of pi over 2, which is 2 pi. So sine 2 pi is 0. So we have those numbers. So we have those 5 points. So based on those 5 points, we can connect it. We connect them. We can get the graph for sine. So we can use this, right? X. So we say x here 0, x here. So there's pi over 2. X 0, pi over 2, then another pi over 2, another pi over 2, another pi over 2. So function value is 0, 1, 0, -1, 0. So then we connect those points, so we get a graph like this. Okay. Okay. So we say this is 5 points: 0, 1, 0, -1, 0. Okay. Okay. So here, this graph is produced by computer. So we also can pick pick more points. We can get a more precise graph. But this graph is very precise, produced by computer, right? So here we pick those points. But for us, roughly, so we just pick these 5 points: 0, okay, here 1, 0, -1, 0. So this is sine. Okay. So we see the angle by now can be any angle, can repeat it like So we say this is the only one circle from 0 pi over 2 pi over 2 pi. So we can let the angle turn around again and again. So the graph is like repeat again and again. 0, so 1, go up, like go down. So here just go up, go down, go up, go down continuously. So here repeat. Okay, so we say this sine graph is a periodical function, and from here one circle is one period. So from here to here is one period. From here to here, one period, right? So for a cosine function, the same story. We just pick this 5 points. X, there's 5 typical angles. X equals 0, x equals pi over 2, x equals pi. We just use, again, just use this 5.0, pi over 2, saying another pi over 2, or another pi over 2, like here, pi over 2, pi over 2, pi over 2 to pi over 2. Just turn along the one circle. So use our calculate, we can find cosine 0. Cosine 0 equals 1. Cosine pi over 2 equals 0. And cosine pi is negative 1. And 3 pi over 2, cosine 0. And 2 pi over x equals 2 pi, cosine is 1. So we just like this. Oh, we just have this 5 points. So we say, let's say x0. So we say 0 pi over 2 pi, like another pi over 2 pi over 2. We just there's 5 points. So x equals 0 for y, cosine is 0. So cosine is 1. So 1, 0, negative 1, 0, 1. So connect those 5 points. So graph just looks like that. Okay, so this is cosine. So okay, so 1, 0, negative 1, 0, 1. So it's 5 points. Okay, then we say this sine or cosine, so this angle is also can repeat. So the graph just go up, go down, go up, go down, repeat it again and again. Okay, so here 1, right? So 0, 1, negative 1, 0, 1. Then repeat, right? So just repeat it this way. Repeat again and again. So from here we can see graph for sine and cosine quite the same. Actually, they are exactly the same. Only the starting point is different. So for me, I just remember this. For sine's graph, let's say start from 0. So go up, go down. Okay, so this is sine. Okay. Let's see, start from 0. So for cosine, we just start from here. So maybe we can say let's start from here, like a pi, like go up, go down, go up. So this is cosine. 1, 0, negative 1, 0, 1. So this is cosine. So cosine, sine, only the graph is the same. Go up, go down, go up, go down. Only the starting point, when x equals 0, sine is 0. But cosine is 1. This is the only difference. Okay? Okay. So those are sine, cosine graph. So we can say those are standard sine, cosine. So how about a little bit more general? So general sine, cosine, so y equal a some coefficient sine, so bx plus c. Okay, so uh, so this is a little bit more general cosine. Okay, so for those functions, how can we find? How can we want to? How can we sketch the graph? So we just use 5 points method. We just check those 5 points. So once we have the 5 points, so we just connect them, so we can get the graph, right? Connect those 5 points, then repeat again and again. We get those general sine cosine graph. So let's check some example. Like let's say we want to sketch the graph of this function. Okay, so we just regard ideas. We regard those just this sine function, sine this angle. So here we regard the 2x as this x. Okay. Okay. So for sine this, so we have 5 points. We just regard 2x as one term. So when 2x equals there's 5 points, 5 angles, 0, pi over 2, pi. There's 5, so we know sine value is 0, 1, 0, negative 1, 0, right? Okay, so when this angle, we regard 2x as just one angle. When there's 2x equals those 5 points, 5 angles, so we get the function's value 0, 1, 0. So there's 5 points we should remember almost 0, sine 0, 1, 0, negative 1, 0. But we want to schedule graphs about x, y, not 2x and y. So we just change to x. So let's say, so when 2x equals 0, what is x? So we just need to find those x. So we say when 2x equals 0, x equals 0. So when 2x equals pi over 2, what is x? So we just need to solve for this equation, right? So we solve for x pi over 2 divided by 2 become pi over 4. So we can find those x. So we just say half of them, right, divided by 2. So based on this, so there's 5 points. Those 5 points. X equals 0, y equals 0. When x pi over 4, y equals 1, right? So we pick this 5 points. X equals 0, y equals 0. X pi over 2, y 1. So x pi over 4, 1, pi over 2, x 1. So here's x 3 pi over 4 and pi. So this is become one period from 0 to pi is one period. Then just repeat it again and again and again. Okay. Okay. So the 5 points. We just find those x's. Yeah, we regarded those angle at the beginning. We just regarded those big angle as x. So when this angle is those 5 points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we can get those functions value, y value. So we can schedule graph. Okay. So let's say the cosine. Same story. So here a little bit more complicated. We say y equal 10. So that's equal. Yeah. This function 10 cosine this. So at the first we say we regard this as 10 cosine this angle. Okay. So we regard this is one term. So when 4x minus pi over 3 are those 5 points. When 4x minus pi over 3 equals 0, we know function value cosine 0 is 1, so function value is 10, right? Y equals 10, right? So when this angle is pi over 2, cosine is 0. So 10 times 0 is still 0. So when this angle is pi, so cosine value is negative 1. Then function value 10 multiplied, so become negative 10. Okay, the 3 pi over 2, so cosine is 0. So those cosine functions, so by now we should remember like we say 1. So let's say graph just like that. Just repeat again and again. Just here, there's a 5.1, 0, negative 1, 0, 1. So this is cosine, right? 1, 0, negative 1, 0, 1. Okay, so we can easily get those, right? Okay. So multiply thing just multiply thing like 1, 0, negative 1, 0, 1 become 10, 0, negative 10, 0, 10, right? So here we want to find x and y. So we want to put the points of x and y, not 4x minus pi over 3, right? So here we need so we need to find those x's. We say when say 3x minus pi over 3 equals 0. So we need to find out what is x. So we need to solve for this x. So this is easy, like we just a linear equation. So 4x equal pi over 3. So we say, okay, sorry, 4x equal pi over 3. Saying what is the x? So divided by 4. So this will become pi over 12, right? Okay, so we saving 4x minus pi over 3 equals 0, x equal pi over 12. And then, so we need to solve for this. So let's say 4x minus pi over 3 equal pi over 2. So when this equal pi over 2, what is x? So what is x? So just solve for this equation. Let's say so 4x equal pi over, so we move pi over 3 to that side, constant to that side. Pi over 3 plus pi over 2. So here we need to put them together. Pi over 3, pi over the, so common denominator is 6. And this becomes 5 pi over 6. Okay? Okay, so then what is the x? So x equal divided by 4, so that's equal 5 pi over 24. Okay. Okay. So so here we'll find 2 points. Then we also needed to find when 4x minus pi over 3 equal pi, we need to find that x. And equal 3 pi over 2, we need to find this x. So here it seems like we need find 5 points. We need to solve 5 linear equations. Okay, so we can do this that way, but we find this is a little bit tedious. So here we try to find a better way. Better way is we say those 5 points are same distance, like 0, pi over 2, pi over 2, another pi over 2, pi over 2, right? So here, those distance same, like from here to here, distance pi over 2, increase pi over 2, pi over 2, just like that. So here, from here to here, and from here to here, also the same distance. So in order to find easy to find the distance, so we just changing over here, that this pi over 2 over here, 5 pi over 24. So denominator not the same. So we prefer make denominators the same. So we just use 24. So this become 24 here 2 pi, right? So when x so when 4x minus pi over 3 equals 0, we put the x equals thus 2 pi over 24. So forget the 24, we can find this is 2 pi. Then this is 5 pi, right? So we forget this is 22. Okay, so from 2 pi to 5 pi, it increases 3 pi, right? 3 pi. So we know all those points just increase 3 pi, 3 pi, 3 pi. So 3 pi, 3 pi by now become 8 pi, 3 pi, right? And 3 pi, 11 pi, 3 pi, 14 pi, right? So then divide over 24. So we say if we find 2 points, then we another 3 points, we can really quickly we can determine it. Okay, so there's a graph for cosine. So we just pick okay. So suppose like we just pick those 5 points. X. So here 1, here 0, here -1, here 0, here 1. So this graph is produced by compute. Look, it's quite precise. But idea, if we want to schedule graph, we just use these 5 points, right? X equals those. We just use these 5 points. Then repeat. Okay. So this is general sine cosine function. Okay. So here we have some names, like we say for general those we find is period. We say before is like so before for sine cosine 2 pi from 0 to 2 pi. This is one period. So then here from this point to this point is a period for this function. So period is we say this equal 14. So forget 12, like, forget 24, like minus 2. So its period is thus. We should divide by 24. So this equal pi over 2, right? So we say this pi over 2 is its period. So from here to here, the pi over 2, pi over 2. Okay. Okay. So we say like so in physics we have the name like if period is small, then frequency is so we also define this. What is frequency? Equal 1 over period. So period is small, frequency is big. Okay. So for those functions, so for this, so we can have formula. How can you determine the period? The period is 2 pi over the coefficient for x. And this a, we also have a name. We call this amplitude. Just how much it changed, go up, go down, go up, go down, go up, go down, right? So here, go up, go down is 10, right? So this 10, we call this 10 is amplitude. Okay. Okay, so those are graph for sine, cosine. So how about a tangent? How about a tangent? So again, like we just check 5 points. So we just check a tangent 0 and the tangent pi over 2. But we have some trouble. We find tangent pi over 2 is undefined. If we use calculate, it may give us error message. So why tangent pi over 2 not work? Okay, so let's say let's check why we so in order to explain this, why pi over 2 tangent pi over 2 does not exist or not work. So let's say, so we have this relationship, tangent equals sine over cosine. So let's check like what is tangent. So we defined from lateral angle. Suppose it's A, B, C. This tangent this ratio B over A, right? And this B over A, if we just we divide by C, B over C over A over C. So this B over C is sine, and A over C is a cosine. So we have this relationship: tangent equals sine over cosine. Okay, so this is a general relationship: tangent equals sine over cosine. So we can say that in our calculate, so actually like we don't need a tangent. If we only need a sine, cosine, right? But say we have a tangent just for our convenience, right? So we can check a tangent directly, and also we can check a tangent from sine over cosine. But here sine over tangent equals sine over cosine. So so we use this. So we can regard this function as rational function. We have a denominator. So denominator, we have some basic requirement. We say those denominator cannot be 0, right? So if those denominators equal 0, we say cosine x equals 0. So those are asymptotes. So for tangent function, we have vertical asymptotes. Denominator equals 0. So let's check when the cosine equals 0. So we check the graph, right? Cosines, let's say stuff just like sine, but starting from here. Okay, so where the cosine 0? Here and here, those are 0. So this is let's say 0. This is pi over 2. This is point pi over 2, and this one negative pi over 2, and then this one 3 pi over 2, and this one so we can see there's 5 pi over 2. So this we can, so cosine x equals 0, we have many points. So you can check it out. What is this one? Okay, so you can find the way, right? So just a pi or 3 pi or 5 pi. So if you forget pi and forget 2, just like 1, 3, 5, 6, 7, right? I'm sorry, 7. And it goes this way, -1, -3, like that, right? Okay, so cosine function has many vertical asymptotes. No, tangent function has many vertical asymptotes. Okay, and many those are asymptotes. So from those asymptotes, so we just pick two simple ones. So two simple vertical asymptotes is this: x equal pi over 2 or negative pi over 2. So because cosine pi over 2 equals 0, so tangent pi over 2 actually equals sine pi over 2 equals this, like sine pi over 2 over cosine pi over 2. So sine pi over 2 is 1, cosine pi over 2 is 0. So this reason tangent pi over 2 does not exist or undefined or give us error message. Okay, so we can regard a tangent function as rational function. So for rational function, most important thing is vertical asymptote. So we have those two vertical asymptote, right? So we can schedule graph. So we have two vertical asymptote, thus like pi over 2 and negative pi over 2. Okay, and when x equals 0, function value equals 0. So the graph is here go up, positive, like go up, approach this asymptote, and here negative, so go down, approach to this asymptote. So this is tangent graph. Tangent graph. Okay, so this is a graph from compute. Tangent like so this point 0, right? So go up, go down. So here just repeat again and again. Go up, go down, just like that. Okay. So we say for tangent, we just remember tangent function has those two vertical asymptotes. So this is for standard tangent. Then for general tangent, let's say like suppose we say equal to tangent 3x. Okay, for this function, so we just regard 3x. So we have vertical asymptote is 3x equal pi over 2 or negative pi over 2, right? So positive, negative. So those are most important. Oh, sorry. Why? Okay. Okay. Those are important, most important things. Okay. So positive, negative. So we have two vertical asymptotes. So once we have the two vertical asymptotes, we can easily schedule graph, right? So we get there's two asymptotes, then graph like that. Okay. Then repeat. Okay. Okay. So this today's topic is we mentioned two things: radio. So by now we measure angle in radio. Then we can use radio for our graph. So those radio is just regular numbers. So the function for those graph y equals sine, cosine, tangent, those graph, and y equals those polynomial functions graph, we can use the same rectangle coordinate, right? Okay, so there's today's class. So thank you. So we can stop again. Thank you for watching.